So we talked a lot about waste in this unit. Alright, and we talked about those items that you can recycle. Alright, we need to keep those things out of landfills. We talked about the organic portion of our waste, which can be composted. Alright, then we talked about that other type of waste, mostly packaging and things that you can't recycle, and those things need to go to the landfill. And now it's time to talk about hazardous waste, the other type of waste that you can't recycle, you can't compost it, we should not put it in a landfill. What we need to do with it is actually manage it. Alright, sometimes management means burning it and then getting it into a landfill when it's less hazardous, but we really need to manage this waste properly. So that's where we are today in this lecture. And hopefully you get a sense for how important it is to not only manage our waste when it's being generated and when it's being stored, but also the proper disposal is something that we need to be concerned of. The EPA estimates that U.S. industries generate 256 million tons of hazardous waste every year. Of that, 40 million tons are released into the environment. Alright, so if we're generating 256 million tons of hazardous waste per year, and a large portion of that is actually being leaked into the environment through illegal dumping, through improper disposal, mismanagement, smokestacks, that's a concern. Alright, so we need to be really aware of our hazardous waste and how to dispose of it properly, how to manage it properly. There's all kinds of chemicals and toxins and materials when it comes to hazardous waste. Alright, we're talking about things like acids, CFCs, dioxins, anything that's explosive, some heavy metals, lead, mercury, cadmium. We're talking about things like infectious waste, pesticides, radioactive waste, just to name a few of these materials that we can consider hazardous. So what is the definition of hazardous? By definition, what it means to be hazardous waste is anything that's fatal. Anything that's fatal to humans or lab animals in low doses we can consider hazardous. Anything that's toxic, and those toxic materials cause cancer or mutations at the genetic level. All right, anything that's ignitable or flammable. Anything that's corrosive. All right, anything that's explosive is obviously hazardous, or anything that's radioactive. All right, these are the key words here that make a type of waste or make a type of material hazardous, and that should make sense. Alright, so when you turn the side of a canister and you look and you see words like flammable, alright, well, first off, if you see the word danger and you continue to read and you see flammable or ignite explosively, you're dealing with something that's considered a hazardous waste, and these are the products and materials that we cannot throw into a landfill. Right, these things should be managed properly, taken to a proper recycling center or recycling event. Please, if you see these types of labels on a product you're about to dispose of, make sure it's either emptied or dried up and solidified. All right, if there's still material in those containers, you cannot throw those away into a landfill. They need to be properly managed. So let's dive in here and talk about a couple of the terms here that you're going to see and hear regarding toxic and hazardous wastes. So the first one is toxicity. All right, you'll see hazardous, toxic, poisonous. You'll wonder to yourself, what's the difference between those terms? And there really isn't much of a difference. All right, we're talking about substances that are harmful, they cause illness, injury, or death. All right, we're talking about substances that are hazardous or toxic. Okay, the first term here is dose, and this is something that should be a little bit of a review for you. We're talking about the amount of a substance or the concentration over time. Alright, when you think about a dose, think about taking medicine. If you take a solid medicine, you take a dose in milligrams. You might take an Advil or an aspirin, and you're taking a 200 milligram tablet every 4 hours. Alright, that's the dose. If you take liquid NyQuil, you're taking it in milliliters. You might take 5 milliliters every 12 hours. All right, when we're talking about atmospheric pollutants or atmospheric particulates, we talk about it in parts per million or parts per billion. All right, that's where technology has gotten us. It's gotten us to a place where we can measure atmospheric particulates at the parts per billion. Those are just a couple of the ways we measure different substances by dose, amount of a substance or a concentration over time. And I can give you a quick example here with carbon monoxide. If you have a wood stove at your house, you should have a carbon monoxide detector. And what that's going to do is it's going to detect the concentration of carbon monoxide in parts per million in your house. All right, you should have none, because carbon monoxide is an odorless, colorless gas that is very deadly. Okay, if this substance builds up in your home, you could feel effects anywhere from dizziness to death. All right, and just to exercise some of these concepts and a review for you, with carbon monoxide, you can be exposed to 8 parts per million on a 24-hour period before you start feeling your effects. So this is called the threshold. All right, that's when you'll start feeling the effects. So at 8 parts per million over a 24-hour period, you'll start feeling dizzy. Alternatively, if you get 35 parts per million in a 1-hour period, you will also feel dizziness. All right, that's the threshold. So 2 different doses, one over the long term, one over a shorter term, similar effects. All right, and that's the threshold. If you get higher than this, hopefully your detector will go off and it will alert you to the fact that carbon monoxide is leaking into the air of your home and that you need to open your windows or vacate the premises. Okay, don't forget your pets. So that's a little bit of an example regarding dose and carbon monoxide. Continuing along here, I wanted to remind you that it's all about genetics. Okay, some of us will feel the threshold earlier than others. All right, and it makes it very difficult to do research in regarding toxic effects in people. All right, because we all have different thresholds. I'll give the example of one of the more toxic occupations in our country is a nail salon, working in a nail salon. All right, you might have a woman who's been working at the nail salon for 25 years, and she's been exposed to acetone every day for those 25 years, and she doesn't get sick. However, a new employee of only 2 years being exposed to acetone might get sick. So we all have different genetics. It's all about the threshold, which makes it very difficult to do research in this field. But continuing along here, here's what's so important in regarding toxic materials. Things that are soluble dissolve easily in water. If you have a toxin that's insoluble, it does not dissolve in water. You could think of that toxin as immobile. All right, so let's say something comes out of a smokestack and gets deposited on soil, and it's insoluble. It's not going to go anywhere. It's going to sit on the soil. So a different example is if you have a factory and the soil is contaminated with an insoluble material, you can simply remove the soil. Or better yet, you can use phytoremediation and use plants that will, in their roots, suck up or absorb those contaminants, and then the contaminants are stuck within the plant. So you harvest the plant and treat the plant as hazardous waste. However, if you have a toxin or a material that is soluble in water, all of a sudden now it can move, and that becomes very dangerous. So if it comes out of a smokestack and it reacts with water in the atmosphere and it becomes acid rain, and it can move really far distances. Or if it gets deposited on the soil, rainwater can make it move down into the groundwater table. Now you have a contaminant moving very quickly underground to a creek, stream, or river, and it can get into the food chain in that way. If it's soluble, it can also move through the cells in your body. All right, and that's when it becomes very dangerous, when soluble materials that are toxic biomagnify up the food chain and then bioaccumulate within our bodies and within our cells. All right, so keep that in mind. Those toxins that are soluble are very dangerous because we don't really know the synergistic effects. All right, some of these chemicals that we're exposed to on a daily basis are building up in our bodies. So if, for example, we're absorbing brominated flame retardants and you eat a lot of fish and you're exposed to mercury in your diet, and you live in an area where there's a lot of dioxins in the atmosphere and sulfuric acid is a problem, and you're exposed to TCE in your groundwater for some reason. All right, we don't know what's happening within our bodies when these chemicals and toxins interact within our bodies. That interaction is called the synergistic effect. A lot of people are doing research in this field right now. We are a living experiment. We've never been exposed to so many chemicals in human history. So we're doing a lot of research. We're trying to figure out the synergistic effect of these toxins and these materials. If you need to stop here and refresh on bioaccumulation, please do. If not, just fast forward us a little bit. But to remind you, biomagnification is all about the food chain. If we look at a toxin like mercury, all right, something that was being introduced into the water in Minamata, Japan. All right, that mercury was first being consumed by plankton. Now, the plankton has very little mercury within it. However, as the small fish eats the plankton, all right, that toxin is going to magnify up the food chain. It is now in the small fish. And because the small fish eats a lot of plankton, it's bioaccumulating within the small fish. Therefore, when the small fish is eaten by a seal, which for some reason looks like a rocket ship, that toxin, mercury, will then also biomagnify up the food chain and bioaccumulate within the seal. At the top of the food chain is the polar bear, which has the most amount of mercury within its system. The meat of the polar bear is toxic in this way. It can almost be considered hazardous waste. But guess who else is at the top of the food chain? We are. So as we eat fish over and over, if you have a diet that's high in fish, you're being exposed to higher levels of mercury, and you may or may not have a low threshold for that particular contaminant, and you might feel effects. All right, so bioaccumulation is within our bodies. All right, and typically they accumulate within the fats of our bodies, and when you're talking about the food chain, a contaminant biomagnifies up the food chain. So that should be a review. Alright, so this is another reason why, if you're a fisherman, you need to be concerned about the water quality in which you are fishing. How contaminants move up the food chain. So here you go, you have contaminants that are washed into the water. It could be a rainfall event of an industry nearby that's spewing things out of their smokestack. However it gets into the stream, all right, it's going to be the bottom dwelling organisms like the mussels and the plankton that gets eaten by the small fish, and it biomagnifies up the food chain, and then we eat the bass or the trout in the freshwater, for example, or the salmon or the tuna. Okay, so it's those predator species that we tend to eat because we're at the top of the food chain, and we have to watch out because those are the ones that have concentrated toxins in their tissue. Okay, two types of effects of exposure to contaminants or hazardous materials. Alright, the first type of effect is acute, and that's simply immediate effects. Alright, immediate health effects due to exposures to a substance is acute effect. So, for example, radiation burns or itchy rash that you get from touching poison ivy. Alright. You might get headaches or get dizziness after being exposed to a certain substance. There might be death. All right, you can have death as an acute effect. All right, so any type of immediate effect from the exposure of a substance is an acute effect, as opposed to any long-term effect after exposure to a substance would be called chronic. Long-term effects are usually things like cancer, all right, kidney disease, respiratory problems, any endocrine disruptors. All right, chronic effects of exposure to certain materials, it could be from a single dose, some point in your life. Especially with the chemicals and toxins that we're exposed to nowadays. All right, there's thousands that are untested. We might get a single dose early in life, or you might get a blast of benzene from a car exhaust, and later in life you develop some type of chronic effect. So it's one of the reasons why we need to really limit our exposure to things and be careful and use gloves and stay out of exhaust. All right, you need to be real careful. Another example would be phthalates. All right, that's spelled wrong. Phthalates are a known endocrine disruptor, and over the long term of chemical leaking into, let's say, water bottles, you're exposing yourself to phthalates. So we need to be real careful with the choices that we're making. We have to be careful that these things don't bioaccumulate within our bodies. Okay, none of this discussion is meant to scare you or make you nervous in any way. It's my job to present these topics and concepts, but I also care very deeply about people, and especially young adults. That's why I am in the job that I am in, and I do enjoy presenting this information so that you are aware of some of the potential negative effects of the choices that we make on a daily basis.